Hello students, myself Hanis Bansal. Today we will continue our topic matrix. In the previous video lecture we have discussed the basics of matrix and some types of matrix. In this video we will discuss property of matrix, addition, subtraction, multiplication. First of all we will discuss that addition and subtraction of matrix. Addition and subtraction of matrix. 2 and more than 2. 2 and more than 2 matrix will be add and subtract if 2 or more than 2 matrix 2 या more than 2 हो will be add and subtract हो सकती है if condition क्या होनी चाहिए they have same order, otherwise not. 2 और more than 2 मैट्रिक्स हैं will be add and subtract. वो add और subtract तभी हो सकती हैं if they have same order, यदि उनका order same है, otherwise not. For example that matrix A is 1 2 3 4 5 6, matrix B is -1 -2 4 -5 -1 6. We know that in this matrix A order is 1 2 row 1 2 and 3 column. Order of matrix B 2 row and 3 column. Order of A is equal to order of B. 2 multiply 3 is equal to 2 multiply 3. Order of A is equal to order of B. These two matrices A and B have the same order, so we can find A plus B. If we want to find A plus B, 1 2 3 4 5 6 A plus B, -1 -2 4 -5 -1 6. In the addition of 2 or more than 2 matrices possible when their order are same, and in addition their corresponding elements will be added. A11 A11, 1 plus -1 is 0, 2 plus -2 is also 0, 3 plus 4 is 7, 4 plus -5 5 plus -1, 6 plus 6 is 12. 2 multiply 3, it is the A plus B. Similarly we can subtract and we can find A minus B. A is 1 2 3 4 5 6 minus, and B is -1 -2 4 first row is, and second row is -5 -1 and 6, and we let A minus B is equal to corresponding elements will be subtracted. 1 minus -1, overall result is 2. 2 minus -2, overall result is 4. 3 minus 4 -1, 4 minus -5, overall result 9. 5 minus -1, overall 6. 6 minus 6 is 0. So it is the add and subtraction of 2 and more than 2 matrices. 2 or more than 2 matrices will be add and subtract if they have same order, otherwise not. Be order same hai, then they will be add and subtract. If order are not same, then they will not be add or will not be subtract. In this example that matrix of A is order of 2 multiply 3, and order of matrix B is also 2 multiply 3. So A and B will be add and will be subtract. It is A plus B and it is A minus B. Property. First, A plus B is equal to B plus A. commutative law. It means we can also say that addition of matrix obey commutative law. Similarly, a plus b plus c is equal to a plus b plus c. It is known as associative law. We can also say that addition of matrix also obey the associative law. But here we can say that a minus b is not equal to b minus a. A minus b is not equal to b minus a. Fourth, if clay multiply a plus b, a and b two matrices for addition same order. A and b are two matrices of same order, and clay be a scalar. Any real number, complex number, then we let clay a plus clay b. It means that, for example, that we have if 2a plus b, then we can say that 2a plus 2b. It is the sum properties of addition and subtraction. Similarly, we can add and subtract 3 matrix, 4 matrix. So it is the logic of addition and subtraction of matrix. Write down, then we will discuss further. 2 or more than 2 matrices will be added and subtract if they have same order, otherwise not. If 2 and more than 2 matrices have the same order, then they will be added and subtract, otherwise not. It is the example. So students, our next example is that matrix A is 1 2 3 3 1 minus 1. Matrix B is 2 1 minus 1 1 2 0. Find matrix C. We have to find a matrix C where it is given that A plus 2b plus c is equal to 0, and it is given that 0 is a null matrix. Now we solute that. First of all, it is given that a plus 2b plus c is equal to 0.St of all, here see that we want to a, 2b and c. We want to add. If we want to add or subtract 2 or more than 2 matrices, then their order will be same. Now check the order of A. 1 2 3 row, 2 column. Order of B is 3 row, 2 column. Order of A is 3 multiply 2. Order of B is 3 multiply 2. If a matrix multiply any scalar number, then there is no effect on the order. मैट्रिक्स लॉ किसी भी स्केलर से मल्टीप्लाई करने पर उसके ऑर्डर पर कोई इफेक्ट नहीं पड़ने वाला. ए बी ऑर्डर आर सेम. इफ वी वांट टू ऐड सी in B and A, then order of C will also 3 multiply 2. If we add and subtract 2 or more than 2 matrices of same order, then the result is also a matrix of same order, 3 multiply 2, because 0 is a null matrix. So first of all, we have to find the order of 0. Here we want to add A, B and C. Order of A is 3 multiply 2, order of B 3 multiply 2. If we want to add the matrix and subtract the matrix, then their order will be same. So order of A is 3 by 2, order of B is 3 multiply 2, and similarly order of C will also 3 multiply 2, and the result is also a matrix of order 3 multiply 2. Now put the value. Matrix A is 1 3 2 1 3 minus 1 plus 2 multiply complete matrix B 2 1 1 2 minus 1 0 plus C is not given, and it is also a matrix of 3 multiply 2 0 mean all the entries are 0. In a null matrix or 0 matrix, all the entries are 0, and we have 0 is a 3 multiply 2 order 6th element, so all the 6th element like this will be 0. If we want to A and B, first of all B multiply by 2. If a matrix, here is a property, if a matrix multiply a scalar quantity, if a matrix multiply by a scalar quantity mean multiply by a number, then all the entries of the matrix multiply by this number. Mean 1 3 2 1 3 minus 1 plus, if we want to multiply this matrix by 2, then all the entries of this matrix multiply by 2. 2 2 are 4, 2 1 are 2, 2 1 are 2, 2 2 are 4, 2 multiply minus 1 is minus 2, 2 multiply 0 is 0. Plus C, all the entries of in a null matrix are 0, 3 multiply 2. If we want to add two matrices, then their corresponding elements will be add. 1 plus 4 is 5, 3 plus 2 is 5, 2 plus 2 is 4, 1 plus 4 is 5, 3 plus minus 2 is 1, minus 1 plus 0 is minus 1, plus C is equal to, all the entry will be 0 is in right side. If we want to find C, this matrix is in add with C, then by transport it will be subtract. By transporting rule, it is in the add, so by transport it will be subtract. Subtract 5, 5, 4, 5, 1, minus 1. By solving this, 0 minus 5 minus 5, 0 minus 5 minus 5, 0 minus 4 minus 4, 0 minus 5 minus 5, 1, sorry, minus 1 plus 1. It is the answer we have find matrix C. It is the property that A is B is find matrix C where A plus 2B plus C is equal to 0, where 0 is a null matrix. So it is given that A plus 2B plus C is equal to 0. If we want to add and subtract two or more than two matrices, then their order will be same. If we want to add A, B and C, so their order will be same. Order of A is 3 multiply 2, order of B is 3 multiply 2. So it is clear that the order of C will also 3 multiply 2. And the result is also a matrix of the same order 3 multiply 2. It means that 0 matrix of order 3 multiply 2. It means all the entries of this matrix of 3 order 2 will be 0. Now here is a property, if we want to multiply a matrix by a scalar quantity, then all the entries of this matrix will be multiplied by this scalar quantity. 2 2 are 4, 2 1 are 2. Add these two matrices and then transport these two matrices. We will find the matrix C. Now write down this question. So students, now we will discuss product of two matrices. Our next topic is product of two matrices. Let's start. A and B are two matrices if we want to multiply AB, then it is possible if main condition if. It means that if we want to product of two matrices, possible if number of column in first matrix, mean in AB in A, is equal to number of row is second matrix, mean in B. If we want to multiply two matrices, it is possible if number of column in first matrix is equal to number of row in second matrix. Then the product of two matrices is possible, otherwise they are not possible. If number of column in first matrix is equal to number of rows in second matrix, then their product is possible, otherwise the product is not possible. It is the only single condition to find that product is possible or not product is possible of two matrices. For example, that we have two matrices A and B. A matrix is 4 2 minus 5 1 0 3. B is 6 minus 7 0 minus 1 2 5 1 0 3. find AB, BA if they exist. Mean first of all we have to find that AB and BA are exist or not exist. If they exist, then find AB and BA. So in solution, first of all we will try to find AB. If we want to find AB, then first of all check the order of A. Order of A is 2 row and 3th column. 2 multiply 3. And order of B is 3 row, 3th column. Order of B is 3 row, 3th column. It means that B is a square matrix. We can say that B is a square matrix, but here is not row of square matrix. Now, if we want to find AB, number of column in first matrix, number of column in first matrix, number of row in second matrix. In the previous video we have discussed if order of a matrix is m cross n, then first number show number of row and second show number of column. Number of column in first matrix, the number of column in first matrix is equal to number of row in a second matrix. So we can say that AB is exist. AB is exist. So we can find AB. AB is exist. Now the process of find AB. A 4 to minus 5 and B is 1 0 3. B is 6 minus 7 0 minus 1 2 5 and 1 0 3. So first of all check that order of A is 2 multiply 3 and order of B is 3 multiply 3. Number of column in A is equal to number of row. Now we can find AB and the order of AB is 2 multiply 3. Order of AB is 2 multiply 3. It means that AB contains 6 element. AB contains 6 element. Contains 6 element means that A11, A12, A13, A21, A22, A23. 2 multiply 3 mean 6 element, 2 row and 3 column. 2 row and 3 column, it is AB. Now how we can find AB? First of all check it. First row, first column. First row, first column. Number of column of AB is used in the formula remaining number of rows. So we use row of A and column of B. A11, A11 means first row, first column. First row, first column. 4 6 are 24. 2 multiply 1 minus 2 minus 5 multiply plus 1 minus 5. A12 first row, second column. First row but column is second. Column is second. First row 4 multiply minus 7 minus 28. 2 multiply 2 4 minus 5 multiply 0 plus 0. First row, second column. First row, third column. Row is first but column is third. 4 multiply 0 0. 2 multiply 5 plus 10. Minus 5 multiplies 3 minus 15. It is complete the first row. Now we second row, first column. Now we will use second row. Second row, first column. 6 6. 0 multiply minus 1 0. 3 multiply plus 1 3. Second row, second column. Second row, second column. 1 multiply minus 7 minus 7. 0 multiply 2 0. 3 multiply 0 0. Now we use second row, third column. 1 multiply 0, 0, 0 multiply plus 5, 0, or 3 multiply 3 is 9. So we let AB of 2 cross 3 is minus 2 minus 5 minus 7, 24 minus 7, 17, minus 28 plus 4 minus 24, 10 minus 15 minus 5, 6 plus 3 9, minus 7 or 9, 2 plus 3. It is the AB. Now we will discuss about the existence of BA. If BA is exist, then we will find BA. BA. Now, order of B is 3 multiply 3 and order of A is 2 multiply. Multiplication of two matrices will possible if number of column in the second matrix will be equal to number of row in first matrix. Here number of column in B, number of column in B is not equal to number of row in A, not equal. 3 multiply 3 is not equal to 2, so BA is not exist. If BA is not exist, then we cannot find BA. BA mean it is very simple topic. Product of two matrices. Product of two matrices will be possible if number of column in the first matrix is equal to number of row in second matrix. Number of column in first matrix is equal to number of row in second matrix. For example, we can see that if we want to find BA in this example, that let's see that order of B is 3 multiply 3, 3 row 3 column, and order of A is 2 row 3 column 2 multiply 3. Number of column in first matrix B 3 and number of row in second matrix 2. 3 is not equal to 2, so BA is not exist. And in AB, number of column in first matrix 3 and number of row in second matrix 3 equals, so AB is exist and we will find AB, and the order of AB is remains 2 multiply 3. It means that AB contains 2 row 3 column with 6 elements. It is the process of finding AB. First row, first column 1 1, first row second column 1 2, first row third column 1 3, second row first column 2 1, second row second column 2 2, second row third column 2 3. Write down, then we will discuss further. So students, our next example is that product of three matrices. 1 H1, it is a matrix, it is a second matrix and it is a third matrix. In this example, it is given that product of these three matrices is equal to 0. And it is also given that 0 is a null matrix of order 1 cross 1. Given that 0 is a null matrix of order 1 cross 1. Two matrices will be equal. Product of these three matrices will be a matrix, and two matrices will be equal if their order are same. It means it is result that the calculation of this matrix, product of this matrix will be a matrix of order 1 cross 1, because two matrices will be equal if their order are same. If in the right hand side the order of matrix is 1 cross 1, then it is clear that in the left hand side resultant matrix will be the order of 1 cross 1. Now we have to find the product of these three matrices. Solution. Before the solution, we have discussed a logic that if we want to find ABC, ABC means product of three matrices, A multiply B multiply C. Then we can find the product of these three matrices. We can find, first of all, multiply AB. First of all, find A multiply B. Result matrix multiply by C. Multiply A multiply B and we let resultant matrix is D. Then D multiply by C. First way. Second, A remaining same. Multiply B with C. Resultant matrix is suppose that D. Suppose that E. Then we find A. But here a important concept that we cannot multiply AC direct. We cannot multiply AC directly. We cannot multiply 1h1 directly to 1h1. We cannot multiply A direct C. We can multiply AB and resultant matrix multiply by C. We can find BC and resultant can multiply with A, but we cannot multiply A direct to C. Mean that 1h1. If we see that it has the order of 1 cross 3. Row matrix, it is 1 3 2 2 5 1 15 3 2 1h1. It is a square matrix of 3 cross 3 and it is a column matrix of 3 row and 1 column, and answer is 0. We can multiply this matrix to this matrix because the number of column in second matrix is not equal to number of row in first matrix, second matrix, sorry. We can multiply this matrix by this matrix. Number of column in this matrix is equal to number of row in this matrix. But we cannot multiply direct this matrix to this matrix. Otherwise, it is obey the condition of multiplication. Number of columns equal to number of row. But we cannot multiply direct A to C. We can multiply AB, we can multiply BC, but we cannot direct multiply A to C. So first of all, we remain same that A. Clear? Now we multiply B with C. If we want multiply B with C, then number of column in this first matrix is equal to number of row in this second matrix. Number of column in first matrix is equal to number of row in second matrix. Now the resultant matrix have the order of 3 cross 1. Mean 3 row 1 column. 3 row 1 column. 3 row A1 1, A2 1, A3 1. 3 row 1 column. A1 1 mean first of all first matrix, sorry, first row first column. First row first column. 1 multiply 1 1. 3 multiply x plus 3x plus 2 multiply 1 plus 2. 2 1. First row first column. Here no column. Now we will start second row first column. 2 multiply 1 2. Second row 4 multiply x 5x and 1 multiply 1 is 1. Now third row 15 1 ja 15 plus 3 multiply x 3x plus 2 1 ja 2 is equal to 0. So 1x1 order of 1 cross 3, 1 row 3 column, and resultant of this is 3x plus 3, 5x plus 3 or 3x plus 17 of order 3 cross 1 is equal to 0. If we want to multiply these two matrices, then number of column in first matrix is equal to number of row in second matrix, and resultant is a matrix of order 1 cross 1. Mean 1 cross 1, 1 row 1 column mean a single element. Single element mean first row first column. 1 multiply 3x plus 3 plus x multiply 5x plus 3, 5x square plus 3x plus 1 multiply 3x plus 17. It is a single element is equal to 0. We let 5x square plus 3x plus 3x 9, 6 plus 3 9x plus 20, 1 cross 1, and 0 is a matrix of order 1 cross 1. It is given that 0 is a null matrix of order 1 cross 1, and we have discussed that if two matrices are same equal, then their order are same 1 cross 1. If matrices are equal, then their order are same and their corresponding elements are also same. So we let that 5x square plus 9x plus 20 is equal to 0. And it is a quadratic equation. By solving the quadratic equation, we can find the value of x. Find x. By solving this quadratic equation, we can find the value of x. Here we have three methods: factorization method, perfect square method, and quadratic or Subtraction formula. By using this, we can find the value of x. So write down and then we will discuss further. Example. So students, our next topic is transpose of a matrix. What is the topic? Transpose of a matrix. Now we will discuss about transpose of a matrix. A is a matrix. A is a matrix. By interchanging row and column of a matrix, we will get a new matrix which is called transpose of a matrix, denoted by A transpose or A dash. Mean, if we have a matrix of any order, if we have a matrix of any order, by interchanging row and column, by interchanging row into columns and column into row, by interchanging row into column and column into row, we get a matrix which is called transpose, denoted by A transpose or A dash. For example, that it is a matrix A. Now the order of A is 2 row with 3 column, 2 multiply 3. It is first row, second row, C1, C2 and C3. If we want to find A transpose or A dash, here are two symbols to denote transpose, A transpose or A dash. If we want to find A transpose, then we have to interchange row into columns and column into row. It means that row, it is the first row. In transpose, it will make first column 1 to A. It is the second row, it will make second column B3 4. And column have also interchanged in the row. First column now make first row, second column is then made second row, and third column is then made third row. Now order of A transpose is 3 multiply 2. It is A transpose. If interchanging the row and column of a matrix, we will obtain the transpose of a matrix. We will obtain. If A is a matrix of order m cross n, Aij its element. A is a matrix, m cross n is order, Aij is element, I number of row, ith row and jth column. If we want to find A transpose, then row and column interchange. Row and column will interchange to each other, Ji ho jayega, and order will also change n cross n. If suppose that here 2 is, which element is A1, 2 is 2. First row, second column. In the transpose, it will make A21. In the transpose, it will make A21. In transpose, A21 is second row, first column 2. A12 is 2, in transpose it will make A2 1. If in a matrix Aij, then in the transpose it will make Aji. It is the transpose of a matrix. Some properties of transpose. First, if we have to find A plus B transpose, then we can write A transpose plus B transpose. Similarly, in the subtraction, in the production it will change. AB transpose is equal to B transpose A transpose. ये सिर्फ लर्न करनी है आपको, ठीक है, नॉर्मली लर्न रखने हैं. और थर्ड प्रॉपर्टी इज दैट इफ A transpose with then A. If we will find transpose of a matrix, it is A. We have find A transpose, and again if we find transpose of this, then we will get again A. Transpose of A is A. Mean it is A. We have find its transpose. Now if we will find the transpose of this A transpose, then we will get again A. If we will find transpose of, mean the transpose of A transpose, it is A transpose. If we want to find its transpose, then change its row and column. First row, first column, second row, second column, third row, third column, or which is equal to A. It is the most important properties of transpose. Okay? So it is the transpose of a matrix. In the next video lecture, we will discuss some properties of transpose known as symmetric and skew symmetric matrix. The classification of a matrix on the basis of transpose. Here are two types, symmetric and skew symmetric. In the next video lecture, we will discuss about this. In this video lecture, we have discussed addition, subtraction, multiplication of matrices and transpose of a matrix and some important properties of transpose. I hope you like the video. So please like and share the videos. Okay, goodbye students.